And so now we're going to talk about reporting data. The context now starting to come into full picture. What are we trying to say? Creating meaning for the scores. I made a 68 microbiology. That sounds bad. I mean, I made a D, but you look at the 44% of the other people that either made a 68 or less. You know, again, there are a lot of people who failed that class. The context is I made a D and it doesn't sound so great, but we flipped this coin over. Now I was part of the 56% of the people who passed, right? So a little bit more than half the people passed that class. So now we're looking at a 68 and it doesn't sound so bad. Now we're, again, context. You are a baseball player and you're at bat and you swing, you miss, you swing, you miss, you swing, you hit the ball. So you hit the ball. That's great. One out of three opportunities, you actually connected the ball. But that third opportunity, you hit a home run. So now we're changing the context up a little bit. So we're again reporting data. What are you trying to say? What is the end state, the bottom line? Where are we going? Don't start anything without the end in mind, right? So what is it you're trying to get across? And this is how we help create that context. This is how we, as biomathematicians, start categorizing things. And it's called frequency distribution. It helps us organize the data. It involves the use of the word frequency, obviously. Helps understand what a percentile is. And if you look at tables 3.1 and figure 3.1, you can see how using this data it seems a little spastic at first, but once you start thinking about it, it starts making sense. And this is how we start tracking records and things like that. So evaluations are scores, but only one score doesn't mean much. It needs to be compared. So again, normative and criterion-based comparisons. How do we compare? And we use a frequency distribution to do so. So again, in reporting data, I briefly talked about percentile and percents. So let's distinguish the two. A percentile out of the textbook says it represents the sum of percentages of observations at or below a given score. So let's put that in context now. So basically, it's a group of people, right? So it's another way to skin that cat. It's another way to say you fall within a group of people, you're in this percentile. So your percentage falls within this percentile. Table and figure 3.1, again, we got to use that data. Then it gives us the hypothetical that you have a score of 46 milliliters per kilogram per minute VO2, and that falls within this 26th percentile. How do we get to 26th percentile? So you look at the data again, there's 5 people in this total population of 65. That represents 7.9%, 7.69% of that entire population. But it's still not exactly a percentile. So basically, you look at the other people who scored the same or below and use those percents and add up to the 26.2 percentile. So that's 1.5% plus 4.6% plus 4.6% plus 7.7% plus 7.7%, and that adds up to 26.2. So again, in context to VO2, that's a pretty low score. You know, we obviously want to see scores anywhere between 56 and I think it is above for certain age ranges, and we'll talk about populations in a further chapter. But let's change the context a little bit. So if we're not talking about VO2, we're talking about GOF. 46 would be considerably low. So, or the 26th percentile would be considerably low. You look at how to change that over, you subtract that 26th percentile from 100, and now you have the 74th percentile. And so that's how you get into that upper percentile margin. Central tendencies is a pretty easy topic in this chapter. So when you look at central tendencies, there's 3 terms you need to be really familiar with. You need to know how to have your mean and your mathematical means to create a mean. Mean is nothing more than average. It is abbreviated with a capital M. Median, generally spelled out as median. It's the middle score. So out of 3 scores, 1, 2, 3, obviously 2 would be the middle score, 2 would also be the mean. The mode's the most frequently scoring, so now we got to have a few extra numbers here. Let's do a 1, 2, 2, 2, 2, 2, 3. Again, that changes the median in the average pretty minutely. So, but it changes the mode because now you have a mode. So you have 2 as a mode. Distribution shapes. So now we're going to start showing you visual data and what it represents. So some more terms we're going to hit here. Skewness. Typically a range between +1 plus or -1 to -1. So it's going to change a few things on the bell curves that we'll see in the next slide or two. Kurtosis just means the top of the slide or top of the curve. So you're looking at where the curvature rounds out. Positive and negatively skewed skewed distributions you'll see on the next slide. Basically, is with where you talk about that +1 to -1. So you'll see a bell curve, but the hump is closer to the left versus a bell curve where the hump is to the right. The normal or no skew bell shape basically is what I keep talking about as a bell shape. That's the normal skewed or non-skewed. It's also considered the mesocuric curve, so it's in the middle. Platycuric, it somewhat means plateaus. So when you look at the curve, you'll understandably see what platycuric means. Is just a very low distribution worth of numbers. The leptocurtic is the complete opposite of that. So when you see a more narrow margin or central mean, that means the curve is going to go all the way up or have a much higher kurtosis throughout the data. And here again are those distribution shapes straight out of the textbook, figure 3.2, figure 3.3. The difference, you can see the mesocurtic is pretty symmetrical right and left. The platycuric and the leptocurtic are also symmetrical, but you see the magnitude of their frequencies. So you look at the platycuric, it's a lot more flatter than the mesocurtic versus the leptocurtic, which is very pointy, I guess, without actually being pointy. Is just a higher magnitude where the numbers round out. On the right here, figure 3.2 is where we talk about the +1, 0, -1. So it sounds confusing, but the +1 is your negatively skewed versus the positively skewed, which would be the -1. You'll see what that means when we apply the z-score and standard deviations. So that's what that +1 and -1 really mean. Variability. So now we're going to start putting numbers to those bell curves. The spread of distribution of scores. Basically, you're looking at a range, your variance, and your standard deviation. So if you pay attention to some of this, it'll come by real easily. It's obviously it's more mathematically driven, so you need to practice it. But the concepts are a little bit more straightforward than the last several or series of slides have been. Let me just take a few seconds to talk about range. It's one of the easiest to come up with. Basically, it's the least stable because it only uses 2 numbers, and there's not much you could do with it, honestly. But to figure out range, you basically take the max and subtract it from the minimum. That's it, So if you have 10 scores, out of those 10 scores, you have let's say an 11 as your highest score and a 1 as your lowest score, then you have a range of 10. All right, and under variability, unlike range, we are going to spend a little more time kind of going over this. Obviously, there's a few more steps involved. There's more of a definition, and if you look at the mathematical process, obviously, you can see it's a little bit more complicated than just taking the one number and subtracting from another. So variance, right, measures the spread of a set of scores based on the squared deviation of each score of the mean. So very wordy. Let's put that into context. It seems more simplified. But to discuss variance, it's the most stable. You have more numbers to work with. You can, create true percentiles. You can create standard deviations. You can create a whole bunch of different numbers based off of this. And it's the most frequently used out of all the variabilities. So in steps, first off, you want to find the mean. You want to find the mathematical average. Then you're going to subtract the mathematical average from the score. So again, this probably turned out to being a bad example, but let's say the mathematical score was 11, but the mean was 5. So you would subtract the 2, and now you have 6. So the next couple of slides, we'll explain that in more detail. Then you got to square the result. basically it creates a result, and you got to sum up all the results. So that's when it gets a little more hairy, so to speak, when you have, let's say, 10 participants versus 300 participants. Obviously you're going to spend a lot more time with the 300 people, but if you know how to program your Excel spreadsheet effectively, that could curb a whole bunch of time. So here's a partial of the table out of the book, table 3.2, and you got all the observed scores, you got the mean, you got the deviated score, and the square deviation score. So here we got a series of numbers, scores. The book sometimes calls it something different, and that's neither here nor there, but in the end, it's just a score. Again, the mathematical mean is you sum up all the scores and you divide it by the number of scores. So if there's 10, which should be, let me take a quick count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so basically you add up all the scores, it should equal 30, and you divide it by 10. So that gives you a 3. So how do we get to the deviated score? So now you're looking at the observed score, subtract the mean score, and that gives you a 0. So 3 minus 3 is 0. 1 minus 3 equals -2, and so forth. And then you take you square each of those deviated scores to get your squared deviation. So -2 squared is 4, because you can never square a negative and yield a negative. You would eliminate each other, basically. The negatives would eliminate each other. And thus, here you have the actual table. So you got the operator, which is minus, and you got the equal sign there. So you're squaring each of them to basically, the total chart there, you get 20. So here I'm asking you to find S squared, or the variance, which again, go back a couple slides, see the math that goes into variance, and cough up a number. Put your answer at the bottom of the comments. Let's see if you can get it, right, without cheating. All right, everybody, I think that's going to be enough for this video. Again, take the opportunity to, one, review the video, rewatch it a couple times, take the time to read the chapter. We do have quizzes and exams that coincide this course material, so make sure you read the chapter. You may not have a full understanding the first time you read it. You may not have a full understanding the second time you read it. So the best way to do this is just to approach it in a very pragmatic style. So read it just to read it the first time, read it to interpret the second time, and read it to memorize the third time. So if you're ever having trouble with any other class that has a lot of wordy material, that's really the best way to ingest it. Take some time, go over the definitions. You can't speak the language if you don't know the terms. That's the best way to really get the context of this textbook, and to be able to use this textbook to, one, make a grade, and two, it'll help you in your career. So, this is a lot of data that I use personally almost on a daily basis. So you can't sit there and say we don't use test and measurements, because we do. I'm a kinesiologist, I'm an exercise scientist, and I do it daily. So if you haven't subscribed to the channel yet, this is how you do it. You go to YouTube. Hopefully you have your free Gmail account, because YouTube has been bought out by Gmail, or Google, so to speak. And again, it's free, so don't have a little conniption if I ask you to have to, sign up for a free Gmail account, but you need to have one to have a YouTube account. So you gotta have your YouTube account to go here to click subscribe, and from subscribe, you should see a little bell icon appear, and when you click on that bell icon, that's when and only when you have a full subscription to the channel. So when I produce the next video, you get a notification saying, hey, Andy made a video, you should probably watch it, it's pretty cool. So that's how you subscribe to a YouTube channel.